CS687 Capstone AWilkinson, video number 3 of 6 total. Approach continued. Complexion induction methodology could use method 1 using angle theta, right-hand side of slide, or using method 2 using region basis combined with delta distance, left-hand side. Method 2 was selected for this investigation. It was considered difficult to use the two methods together because of possible over-constraints. Design. Regions A, B, C, and D were defined. Region A is when the candidate merge point is on the line segment AB. Region B is some percentage of midpoint of line segment to point A or point B. And region C is the remainder of that distance from endpoint of region B to point A or point B. And region D is points on the line outside of the line segment. Segmentation of regions C and D were accomplished as a function of length of line segment. Implementation involving theory conversion to methodology, particularly for region D. The inverse of the input parameter is the associated complexity induction. Complexity induction is always equal to or greater than unity. The paper includes a detailed abstract of the complexity induction theory, which future further research might require editing thereof or updating thereof. As I mentioned, reference 11, thermodynamic approach to the TSB problem, is provided as a contribution towards confident development and conveyance of the complexity induction theory provided herein. Implementation continued. 13 runs were generated for the Qatar previously shown dataset. Code screen capture show means by which the input parameters could be changed. Code screen captures are provided for assistance. Data collection. 13 runs were accomplished on the Qatar dataset previously shown. Solutions with crossovers were considered non-valid. Total path length was obtained. Total complexity induction was obtained. Total delta L and area under the curve was obtained. 4 different types of plots were studied. Plot number 1 for run number 1, where all factors are equal to 1.0 and a complexity induction of 1178 was obtained, which makes sense because 1178 is the number of merges required, merge decisions, merge actualizations, merge events, 1178, to accomplish the solution, arrive at solution. Runs 2 through 11 produced valid results. All the data presented there is considered valid and useful. Surprisingly, 3 different types of solution path types were obtained. All 3 of those solution types were of shorter path than the run 1, which is all parameters equals 1.0, which is the very early presentation of Qatar's traverse path accomplished by the nested triangles based solver. As an approximation, one might take the total complexity induction for all parameters equal 1.0, which is equal to the total number of merge decisions, merge actualizations, or merge events required to construct the full path. One might take that number and multiply it by 1.2 or boost it up by 20%, and that might be very close to the total complexity induction one might expect when using complexity induction in the way it's intended, which is the input parameters are greater than 1 for the left-hand side, for greater than 1.0, greater than unity for regions A, B, and C, for regions B and C, and less than 1 for regions D. A plot is now possible. Runs 7 through 13 were considered not valid because of crossovers. All the data provided therein is considered null and void, and plots are not included. The reason run number one's plot was included is because all parameters equals 1.0, the very unique case, and complete removal of complexity induction theory from the run. This table represents a bit of a surprise. One did not expect an improvement in the path length relative to baseline run, all parameters equals 1.0, and one did not expect 3 run plots that were all improved over run number 1. The plot on the right is complexity induction accumulation on the y-axis and delta L cumulative on the x-axis. This is for dataset ATT48, which is really the 48 United States cities. Run 2, where D values are 0.9. So in this instance, this plot is shown because it has the right number of data points to show a characteristic of the curve. The curve subsets might be considered join points to be completion of layer dissolution, and one can see high density merge events versus low density merge event regions on subset curves.